In this lecture, we're going to talk about how to write a net ionic equation starting with a complete molecular equation for a reaction. So what a net ionic equation is it shows only the chemical substances that are participating in the reaction. It does not include anything called a spectator ion. So for instance, if we have zinc nitrate dissolved in solution, we would write that as ZnNO3, and we put AQ after, and that AQ means that it is dissolved in solution and it's dissociated even though we don't show it as being dissociated. Plus 2, we're going to react this with sodium hydroxide. And when that happens, it's going to form solid zinc hydroxide plus 2 NO3, and that'll be aqueous as well. So that'll be dissolved in solution. So at this point, what we have is the complete molecular equation. It shows the substances that are both in solution and out of solution, or in this case solid. But it'd be nice to have a representation of this reaction that kind of zones in on just the things that are participating in the reaction. That's what the net ionic equation is all about. So to get to the net ionic equation, what we'll do first is we'll go through each of these, and anything that is aqueous we will dissociate into the ions and show those ions separated, very explicitly. Whereas anything that's solid, liquid, or gas, and in this case we have a solid, we keep together, okay, because those are not dissociated. They're not dissolved in solution. The ions are still stuck together. So in this case, what we would have is we would have zinc 2 plus aqueous. We would have 2 nitrates, and we put the charge on. We would have 2 sodium pluses. We would also have 2 hydroxides. And so that shows all of those aqueous reactants dissociate into the ions in solution. And this is a more realistic representation of what exists in that reaction mixture that we have compared to what we were having before, where it kind of looks like they're still stuck together. They're not stuck together, they are dissociated. So if it says aqueous, it's dissolved. You need to break those ions apart. The solid, on the other hand, is not dissociated, and so those ions are still stuck together, and so we'll keep them stuck together. And then this is aqueous, so we'll have 2 sodium pluses, and we'll have 2 nitrates. Okay, so at this point we begin to see something, and that is that these 2 sodium pluses don't do anything. Okay, they remain unchanged on both sides of the reaction. So these are called spectator ions. And spectator ions, they're just, what they do is they're used to bring some other ion to the reaction, and then they kind of get left behind. So we have the 2 sodium pluses, they're spectator ions, and so they just drop out. Okay, we will not include those in this net ionic equation, nor will we include the nitrates, because the nitrates are also unchanged in this reaction. So what we're left with at the end is we're left with the sodium 2 plus, which is aqueous. We have the 2 hydroxides, which are aqueous, and the reason why those don't get canceled out is because they are changed. They go from being in solution to being part of a solid, okay, and that is a change, and therefore they stay in this solution, or sorry, in this equation. And what we're left with is this net ionic equation. Okay, so I'm going to give you guys a chance to have a go at it. So what if we had lithium sulfate, which would be aqueous, react that with barium nitrate, which would also be aqueous, and we would make 2 lithium nitrates, which would be dissolved in solution, and we would have a precipitate of barium sulfate, which would be a solid. So go ahead at this point, pause the video, and take a chance, and try to work through this and try to see if you can come up with the net ionic equation for this reaction. Okay, so hopefully you paused the video and you've got an answer by now. Just to show you the work on it, so we would have 2 lithium pluses, which are aqueous. we would have this one sulfate, 2 minus, which is aqueous. We would have the barium, 2 plus, which is aqueous. We would have the 2 nitrates, which are aqueous. 2 lithium pluses on this side would be in solution. 2 nitrates would be in solution. And then we would have our barium sulfate, undissociated because it's a solid. Okay. So the 2 lithium pluses remain unchanged, they stay in solution. Our nitrates also stay in solution, so that the net ionic equation that we would have at this point would be barium 2 plus the sulfate goes to barium sulfate, solid, a solid precipitate. And hopefully this is what you guys got for your net ionic equation. One more, because I've dealt with solids. This, you can also possibly have a gas or even a liquid form in a reaction. If we take sodium sulfide, solid sodium sulfide, react that with aqueous HCl, we would get hydrogen sulfide gas and we would get NaCl. I was wondering why the things weren't working there. So we would get 2 NaCl. Okay. Okay, I apologize. There should be a 2 on that subscript because there's 2 sodiums per sulfide. Alright, so here is the balanced chemical equation. Again, pause the video for a bit. Try to see what the net ionic equation would be for this. Alright, so in this case, one of our reactants is a solid, and as such, we'll keep that together because they aren't dissociated in solution. So the hydrochloric acid is, though. So we would have 2 H pluses. This is a strong acid, so 2 H pluses plus 2 Cl minuses. That would go to form H2S, and that's a gas, and so those atoms are stuck together. Plus 2 Na plus aqueous plus 2 Cl minus, and that would be in solution as well, so that would be aqueous. And we see that we would have the chlorides canceling out, and that's all we got. Okay, the sodium goes from being in the solid to being in solution, so we can't get rid of that. The H plus goes from being an ion in solution to part of a molecule. Okay. So our net ionic equation for this would be Na2S solid plus 2H plus aqueous goes to H2S gas plus 2 Na plus aqueous. Alright, so I hope you guys got a good idea about how to get to the net ionic equation. It is a very important skill to have because a lot of your answers in AP Chemistry you'll be required to give it in net ionic equation form, and if it's not in net ionic equation form, you could have points deducted.